Welcome back to Measure, Act, Track, where we're teaching you how to use Google's Environmental Insights Explorer. I'm Christopher Bean, a software engineer working on EIE. We're continuing our EIE series with a look at the data. This video will give you a better understanding of the sources and methodology used by EIE for each type of environmental data we provide. First, let me remind you where to go read about our data methodology and sources on the site. There are two main places you can look. When you're looking at a specific data feed like transportation emissions, building emissions, or rooftop solar potential, scroll down until you see About this data. This will give you pertinent information about how that type of data was derived. For additional information, you can visit the methodology site by clicking the link in the About the Data section. You can also always jump straight to the methodology page by clicking the link in the website header. For several kinds of data discussed in this video, our team has used calculations and values based on the CURB tool. CURB, which stands for Climate Action for Urban Sustainability, was developed by the World Bank in partnership with the Global Covenant of Mayors for Climate and Energy, C40 Cities Climate Leadership Group, and AECOM. Some example values we use from them are energy intensities and carbon intensities. To learn more, you can visit worldbank.org/CURB. So, where does EIE get its data from? For each type of data, we have different sources, so let's go type by type. First, let's start with transportation emissions. When it comes to transportation emissions, EIE leverages data that comes from users who have opted into location history. This data is anonymized, aggregated, and then extrapolated to the entire population. EIE uses the vehicle fleet distribution from CURB, which contains passenger vehicles, light-duty, and medium-duty trucks. Heavy-duty trucks are not included in the fleet mix, but because they may still be sharing location history data, their vehicle kilometers traveled, also known as VKT, will be counted. Finally, we apply fuel efficiency and emissions factors sourced from CURB to convert the estimated activity data into total emissions of carbon dioxide equivalents. The factors also take into account all greenhouse gases produced by burning the fuel, including carbon dioxide, methane, and others. We report these numbers as CO2e for inventory compliance. All building emissions data in EIE is based on sources used for Google Maps. We can measure building sizes based on overhead imagery. We label commercial buildings versus residential based on labels entered for businesses on Google Maps, as well as image processing of satellite and street view data. We also estimate the total floors for buildings. Where available, we do this using a 3D model of the world based on high-resolution imagery. Then we apply energy intensity factors sourced from CURB to calculate the total amount of energy each building consumes. Finally, we apply fuel mix distributions with electricity and stationary combustion emission factors for types such as diesel oil and natural gas that are also sourced from CURB. These correspond to the electricity factors published by the International Energy Agency and the International Panel on Climate Change. Emission factors are calculated by the IEA using the electricity generation technologies in the region and national or subnational energy generation emission data. Emission factors in the United States are calculated by the Energy Information Administration and the Environmental Protection Agency instead of CURB. When we apply these emissions factors, it converts the estimated activity data, that is total electricity consumed, into total greenhouse gas emissions. Because city-specific fuel mixes for on-site combustion are not always available and are highly variable across cities, we largely assume a default 50-50 mix of natural gas and diesel oil. The user can adjust this mix by modifying the average fuel emission factor. The factors also take into account all greenhouse gases produced for electricity generation, including carbon dioxide, methane, and others. We report these numbers as CO2e for inventory compliance purposes. The data you see about your city's rooftop solar potential is from Google Earth's imagery. We use it to create a 3D representation of the world so that we can identify roofs and recognize obstructions like chimneys or trees that cast shade on the rooftop. It's important to note that some of this imagery is recent, but some may be from past years. As new imagery comes in, we will update this map and solar potential values. We use data about local weather patterns and the sun's hourly position to estimate how much direct and indirect sunlight every pixel on a rooftop gets. Lastly, we calculate how many viable solar panels fit on each rooftop, and then we aggregate the yearly solar potential at the city level. Across EIE, we've endeavored to follow general emissions accounting principles, our goal being to help cities to report to the Common Reporting Framework. While we have confidence in our source data and modeling, there are a number of assumptions that are used to scale the values and estimate emissions. As we demonstrated in the previous video, EIE has built-in functions to make it easy for you to download all of the data or just the pieces of data that you want. You can do this on each specific data page by scrolling down to the About This Data section, then clicking on the Download or Export the Data link. Even easier, you can always access these options by clicking the download symbol in the upper right corner of each page. For even more in-depth descriptions of our data sources and methodology, we encourage you to visit insights.sustainability.google/methodology. Thank you for joining me.